Let's now take a look at a few exam questions regarding trigonometric equations. The first of which is this one. It's from October-November 2009, paper 12, question 5. And you're going to see that the structure of these questions, most of them are more or less the same. And in the first sub-question, you have an identity question to prove. And then on the second sub-question, you are going to use this identity to solve a trigonometric equation. So the first part actually doesn't have to do with solving trigonometric equations. It's an identity question, but yeah, that's the way it is. So in this one, you have to prove that this identity over here, okay? So let's take a look at it. This is what you have to prove. So this is where you start. The first obvious thing that you need to do is to expand these brackets, and that's what I did over here. And now, once you reach this step, you look at what you have to prove. Always do that. Always keep an eye at what you want to prove. And you have something that is cubed. And here, the only thing that you have is squared. So you have somehow to get sine cube of x and cosine cube of x out of this. And the obvious way to do that is to transform this into 1 minus cosine square of x. Then when you multiply with this, you'll have the cosine cube of x. And do the same thing to this bit over here. Turn cosine square of x into 1 minus sine square of x. And when you multiply this to the sine of x, you'll have the sine cube of x. Okay, that's what I did. Then there are a few things that are going to cut out. You have here sine of x and minus sine of x, and minus cosine of x and cosine of x. And this is what you get. This is what you wanted. And now that you have this, you have to solve this equation. And look, you have here now usually they have hence solve the equation. The hence, you don't have it over here, but you're going to use it anyway. The hence means that you will have to use the result from the previous sub-question to solve it. Here I'm going to use it anyway. So for you to solve this equation, instead of using all this stuff, you just write this one, because you just proven that they are the same or equivalent. And now what do? You have two terms with sine cube of x. So send this to the other side, it becomes 8 sine cube of x. And now how are you going to solve this? The most obvious way is to either divide the whole thing by cosine cube of x or divide the whole thing by sine cube of x. All right? It's better to divide by the cosine cube of x, because then what are you going to have on this side? You are going to have basically sine of x over cosine of x, the whole thing cubed, which is tan cube of x. And this one is obviously 1. All right? Then solve this for tan of x. Cube root of 1 over 8 is 1/2. So x equals tan negative 1 of 1/2. In a calculator, this is the result that you are given, the only one. But you have to look at the interval now and learn or be aware of how the period of the tan function is. So if you add 180 degrees to this result, this is also going to be the 1/2, the 1/2, yes, the tan of that value. And it's still within that interval. So the two possible results are these two over here. Next question is this one. This is from winter 2013, paper 11. Question, where is it? It's this one over here, question 4. Solve the equation 4 sine square of x plus 8 cosine of x minus 7 equals 0 for this interval over here. And then hence, see here, they already showed the hence. Find the solution of the equation, this one over here. Okay, so let's take care of the identity first. Here you have it. In order for you to solve these, you have to turn everything to one type of trigonometric function. In this case, it's going to be the cosine. So you turn the sine square of x into 1 minus cosine square of x. Deal with the algebra, and eventually you'll get quadratic in disguise. use the change of variable, u equals cosine of x, and here you have the quadratic to solve. In this case, I didn't use a quadratic formula, I used instead factorization. Once you get used to this, actually is more satisfying to use factorization than just using the ugly quadratic formula, but that's just me. You could use it as well. I know that eventually I'll get u equals to 1/2 or u equals to 3/2, but u is cosine of x, so I'll substitute it again. So I will have either x equals cosine -1 of 1/2 or x equals cosine -1 of 3/2. 3/2 is 1.5, so it's bigger than 1, so this one is impossible. In a calculator, this is the result that I get, but the interval is between 0 and 360. So I know that I will have another cosine with the same value if I do 360 minus the angle. And this is within the interval. Okay, so I have 60 degrees and 300 degrees, and this is going to be the answer. Then for the second bit, hence find the solution of the equation. If you look at this equation, this is very similar to that one over there, but instead of x, you have 1/2 of theta, right? So what do? You just go to the result and you substitute x by theta over 2, right? So you have either theta over 2 equals 60 or theta over 2 equals 300. Now solve it. So you have theta equals 120 degrees or theta equals 600, but the interval stays the same. So this one is out of the interval. The only correct answer is that one over there. Okay, simple enough. Let's look at the last one. Spring 2014 question paper 11, and the question is question 9. See, the structure is pretty much the same. Chances are that you will going to find one question with this structure as well. It's not guaranteed, all right, but I would say that well above 70% of the questions are like this. Okay, so first the identity, then use the identity to solve a trigonometric equation. In this case, the identity is this one over there. So let's take care of that first. Here it is. Every time you have two different fractions separated by a minus or a plus, the way to solve this in most of the cases, but you look over here, and since you only have one fraction, you have to combine these. To do that, you need to get the same denominator, right? So that's what I did. I got this denominator, right? And I have this numerator. The ones cut out, so I have cosine minus cosine square of theta plus cosine of theta. I can factorize cosine of theta, and I will have this term over here, 1 minus cosine of theta. That is both on the numerator and denominator. Cut it out. I have cosine of theta over sine of theta. This is the inverse of sine over cosine, and sine over cosine is the tan, and that's what I wanted. Then, hence, solve this. So what does the hence mean? Instead of writing this stuff, you put that. Look, that when you have the hence, even if you mess up over here, if you don't know how to solve it, you can still use this result over here and plug it there, right? When you have the hence, this and not that is the thing that you have to use to solve the equation, okay? So you have 1 over 10 of theta equals 4 tan of theta. Obviously, you are going to send this to that side, okay? And then you just solve it. 4 goes over there. So the tan of theta is going to be plus or minus square root of 1/4, which is 1/2. So that the theta is going to either be tan -1 or minus 1/2 or tan -1 of 1/2. Keep an eye on the interval from this moment onwards. In a calculator, this is going to be the result that you are going to have. Obviously, this is below 0, so it doesn't matter, okay? Then you have to do what? You have to add 180 degrees because the tan is going to be the same. The tangent of this angle is going to be the same as that one. And this is already inside the interval. This is 153.4 degrees. And then for this one, the calculator gives you this result. And this is the only one that matters in this interval. if you either add or subtract 180 degrees to this, it's going to be out of the interval. So the two possible results are these two.